Hello, everyone. Before we begin, we'd like to wait for a few minutes for the rest of the participants to join us. Before we start, also, I'd like to request that everyone mute their microphones so that we do not interrupt the presentation. We will begin very shortly. Thank you. All right. Hello again, everyone. I hope everyone can hear me well. Before we begin, once again, we request that all participants mute their microphones. We will not be taking any questions via microphones. If you have any questions during the presentation, please write them in the text chat in Zoom. There is a team of dedicated professionals working on your questions. During the presentation, you will get your answers either during the presentation or sometime after the presentation. All of the questions will be answered. Anyways, it's good to have you all here. Today we're going to talk about dielectric oil regeneration. We've done something similar in the past, but we just wanted to come back to this very important topic and to reiterate some of the important things regarding regeneration, and also give more details about what we suggest can be done about it. So the regeneration of dielectric oil is not by any means a new process. It has been around for many years, and it's been in continuous development over these years. There are standards that include quality criteria now, and we're going to mention the IEC 6422 standard and the Mineral Oil Recovery Guide and criteria for its use, which is the IEEE 57637, and that standard was introduced in 2015. So these standards will give us the necessary definitions and parameters, so we can learn a little bit more about these processes. Those processes will allow us to save a lot of oil through regeneration. In addition, we're going to find out what characteristics of the oil we can improve, because when we talk about regeneration, we'll have to make a clear distinction between regeneration and purification of dielectric oil. So this table here presents the various methods for generating dielectric oil and the capabilities of each process. And this is a very good table because if we do an oil analysis and want to know what process we require to handle the problems with the oil, then we know what to do with any particular type of contaminant. And we can find this information in this table. So what I'm going to say is that all the processes that are associated with regeneration related to the improvement of the chemical composition or characteristics of the oil, they are defined in line 6. And these are contact processes, and they involve percolation, activation with sodium, titration, phosphate, and other elements. So these are all chemical processes. So basically, when we talk about regeneration of oil, we mean a certain technology and certain process. Today, we're going to talk about specific information, mainly about percolation and contact as the regeneration process. Next slide, please. So to begin with, let's first define this subject of the discussion. In this case, we'll take the definition from the C57-106 2015 standard. And it says that regeneration is the restoration of oil by removing pollutants and decomposition products such as acidic polar compounds or colloids. So this is done chemically or absorbed from electrical insulating fluids. And this recovery usually involves treatment with a clay or other adsorbents. And here we have something to talk about. We'll see that, first of all, acidic polar compounds and colloids is the main problem. Therefore, it's very important to remove them from the oil as quickly as possible. And all of those compounds come from the decomposition and oxidation of the oil. Another important thing to note is in the definition is that it's absorption or chemical methods. And from here, we see the difference from filtration, and which is just a purely mechanical, physical process. So let's take a deeper look into those differences. Excuse me just a second. All right. So what's also important to know is that when we choose which process. So just to have a baseline, we can take the C57-637 standard, and it tells us that we basically have two groups of oils. In the table number 1 in that standard, there are two values as reference, and these are the acid number or also called neutralization number, and the interfacial tension. So oil that belongs to group number 1 must be purified. Oil that belongs to group number 2 must be regenerated. Therefore, we must find the minimum and maximum values in the oil in order to determine which process we should choose. So it's very important to know what acid number is and what interfacial tension of the oil is. And we'll address these values a little in a minute, and what their variations imply and how these factors affect the transformer. Needless to say, it's very important to take samples of transformer oil. That allows us to learn about the internal processes of the transformer. So a reasonable recommendation would be to make a complete analysis of the oil that allows us to identify the existing problems. When we detect some changes under normal operating conditions, we can take appropriate corrective action to extend the life of the transformer. Yeah, I'm sorry. Someone's got their microphone not muted, and we hear some fun going on in the background. I'd like to again request that all microphones are muted for now. Thank you. So, where was I? Yeah, well, when we detect some problem, we can detect them early by taking oil samples. And when we do, we can take corrective action to extend the life of our equipment and cause the least amount of damage to it. Now, understanding these changes and the reasons for the changes and having the ability to stop the degradation process before it becomes problematic, it's all important for extending the service life of the equipment transformer, and thus for selecting predictive processes, not just corrective ones. Okay. Next slide, please. So let's start with neutralization number, or acidity. Many times in quality reports, we find this value. It's also called neutralization number or acid number. The neutralization number we're going to take this as the acidity value. The reason it's called neutralization number is that to determine the acidity of the oil, we neutralize it. Basically, we take a what do you call it, an indicator strip, a tape, something very similar to the tapes that are used to measure acidity in swimming pools, for instance. So this strip of paper changes color if the oil is acidic, and when we add a base or alkali to neutralize this acid, the strip will return to its original color. And in the case of transformer oil, we use potassium hydroxide. So the idea is to measure the amount of potassium hydroxide that we have to use to return the indicator strip to its neutral color. And so we now know the acidity of the transformer oil as the neutralization number, as the amount of potassium hydroxide necessary for neutralization. And we measure them in milligrams of KOH per gram. So a large neutralization number will indicate the presence of certain polar compounds that will affect the electrical properties of the oil. And it's very important that acids and polar compounds in the oil, excuse me, they have, excuse me, some very negative effects on the transformer and the oil. So with regard to the electrical performance, or dielectric rather, performance of the oil, we must remember that oil is a non-polar liquid, and that is its most important characteristic, because this is what makes oil a good insulator. Next slide, please. So briefly on how transformer oil becomes oxidized. This slide is familiar for those who were here for the Duval triangle webinar. Everything is just about the same. Here we have a molecular chain, a molecule of oil, generic molecule of oil, let's say. And imagine that the gray and red atoms are the hydrocarbon, right? So there is carbon and hydrogen. So this hydrocarbon is oil, and it undergoes various processes. And under the influence of energy, what happens is that the bonds between atoms break, and the atoms can separate from the molecule. Now, we've seen that gases can be formed in this process, and if we have oxygen in this mixture, which we often do, what happens is another category of substances or compounds can be formed. So we take oil, we add energy, and to that we add oxygen, and what we get is a new series of compounds such as peroxides and alcohols, soaps, ketones, aldehydes, and epoxies as well. So all these compounds have some specific characteristics. They're all polar. All of these compounds affect the insulation ability. And another important thing about them is they all contain an OH group. That means that they have oxygen in their chemical structure. And since they're polar, though, we should be able to capture them. And this enables us to extract these compounds. And this is what makes oil regeneration possible at all. Next slide, please. Next slide. Now, when we have problems with polar compounds, those can be furans, phenols, aldehydes, ketones, what have you, and all of that can be in the oil. The insulating performance of the oil deteriorates. In other words, we're going to assume that one of the main characteristics of the oil is going to be affected. The advantages of, but the advantage of this process here, if you can call it an advantage, but anyway, it's that we will see chemical changes first, and only then we'll see the electrical problems. So if we control the oil and make sure the oil is in good condition chemically, we can make sure that we never reach that critical level of degradation of its electrical performance. So like I said, all these compounds have a very big impact on the transformer. And here you can look at the diagram that shows the ability of cellulose paper, the solid insulation of the transformer, to withstand physical stress or mechanical forces, especially when it's in the acidic environment. The paper impregnated with oil in good condition has a much higher stress-bearing capacity than paper with a higher neutralization number. And here we have the amount in pounds of physical stress that paper can withstand. So what we see here is something interesting. This tells us that for transformers of voltage class lower than 69 kilovolts, we would have an acceptable value less than or equal to 0.2 milligrams of potassium hydroxide per gram of oil. And looking at the graph, we can see this is a very critical value because we already lost a sufficient portion of the physical strength of the paper by the time we reach that acidity. So if we work with transformers in the voltage class higher than 230 kilovolts, we can see that it's all very different because the limit values for this operating voltage are quite significantly lower. Since the paper begins to deteriorate strongly under the influence of polar compounds, and we see its great degradation already at the beginning, that's at the initial stages of the formation of these compounds. And so the technical guidelines in labs revolve somewhere around 0.5 milligrams of potassium hydroxide, which consider it much safer for working with transformers. And however, if you want to be really safe, I'd recommend to use a slightly more demanding value or stricter value in order to maintain the useful life of the transformer and extend its service life as much as possible. Next slide, please. So we've already seen that when we have energy and we have oxygen, we'll find new compounds in the oil, and those compounds will reduce the life of the transformer. Certain natural processes will also take place inside the transformer. They can even damage the oil at a greater rate. And this table here provides information about a test that was performed, experiment that was performed by Doble laboratories in the United States. And what they did is they determined the effects of other elements on the oil. And those elements act as catalysts. And in this experiment, they used iron, copper, and water. And needless to say, all three can be found in the transformer really easy. So first, they did a control test in which the oil temperature was raised to 150 degrees, but the oil did not have any contaminants or catalysts in it. So we see that there were no catalysts and the moisture content was low, say less than 10 ppm probably. And under these conditions, after over 3,500 hours, the neutralization number reached 0.17 milligram of potassium hydroxide. So if we go back, we can see that for transformers in voltage class under 69 kilovolts, that's still within safe limits. But for transformers above 69 kilovolts, now that is unacceptable. And we now have a specific value that serves as the baseline. So from there on, they just added moisture without the metals as catalysts yet. And the amount of water was 50 ppm. And the standard, however, allows up to 35 ppm water. So they began an accelerated decomposition process, increasing the temperature of the sample. So after more than 3,500 hours, they had a value of 9 milligrams of potassium hydroxide. So that means that humidity is an element that really accelerates the oxidation and aging of the oil. And then they used iron as a catalyst, but they used a low concentration of water for the first test. And after the same 3,500 hours, they were able to determine a neutralization number of 0.65. So when we start to see the values that are really surprising is when they make combination of catalysts in the presence of moisture. In the next test, they used iron and moisture. So only 400 hours passed, and neutralization number of this oil jumped to 8.1 milligrams of KOH per gram. So that 8.1 milligrams is quite a lot. And then they went through the same process with copper and a low amount of moisture. After 3,000 hours, the neutralization number was 0.89, and that's also a very high value for the neutralization number. And then they performed the biggest test of them all using copper and moisture. And only after 100 hours, it was found that sludge formation began, and the neutralization number reached 11.2 milligrams of potassium hydroxide, which is extremely high. Remember that it's 0.2 milligrams of KOH, which is the highest value that the standard allows for transformers in voltage class below 69 kilovolts. So yes, and they discontinued the test, by the way, as soon as they got sludge. So we see that inside our transformer, there are elements that we can control, which allows us to extend the life of the transformer. For instance, we can control the amount of moisture in the transformer. We can also, just to a degree, control the amount of metals and the exposure of oil to metals. to reduce their effect as catalysts on the decomposition process. In this here slide, we'll address the other parameter from that table that we've looked at before, and that is interfacial tension. So we have two phases, two chemicals that don't mix, and they will have a boundary, an interface, if you will. So this interface between two chemical compounds, for example, here we have the borders between different substances. For example, it can be between two liquids, or a gas and a liquid and a solid and gas, or two solids even. So what is the interfacial tension? It is a measure of how much force is required for a body, for an object to pass from one phase to the other. As a rule, the presence of polar compounds in the oil dramatically reduces interfacial tension and is more sensitive in the initial period of decomposition when it starts. And this will also be determined by the quality characteristics of the oil, because this effect may be more or less pronounced in the oil. It's now very important to analyze the oil to get these two characteristics, acidity and interfacial tension, and measure them in order to know the condition of the oil and the transformer. Because when we see some deviations from standard, it will be an important sign that something's wrong and the oil is aging prematurely, and also the transformer is aging prematurely. So when we find this, the first thing we have to do is to remove the cause of the problem, and then we can regenerate the oil. Next slide, please. So interfacial tension is measured in millinewtons per meter. And as I've mentioned, it's a measurement of how much force we have to apply to move an object from one phase to the other, and polar compounds directly affect that value. Acceptable values should be greater than 32 millinewtons per meter. Anything from 32 to 28 millinewtons is problematic, and anything less than 28 millinewtons per meter is unacceptable. Next slide, please. Right, so another characteristic and another problem is that polar compounds they increase the affinity of oil for water. As I already mentioned, oil is a non-polar compound, water is a polar compound, and this really degrades the electrical insulating performance of the oil. So it's very important to keep these values in check and under control in our systems. Next slide, please. So now we come to the regeneration. Regeneration occurs when we remove polar compounds from the oil. In addition, we also remove some moisture and some other contaminants. So one thing that we remove without really needing to remove it is the oxidation inhibitor, which will come back in a minute. So by regenerating used oil, we will be able to get the performance characteristics of new oil. And at the end of the oil regeneration process, the oil is basically reset and its parameters are very close to the original oil. What happens is that this process also removes oxidation inhibitors, and therefore, whenever we regenerate oil and we want to maintain the parameters of inhibited oil, then we must add that inhibitor back into the oil at the end of the process. Next slide, please. So inhibitors are compounds that are deliberately added to certain oils to improve the oxidation resistance. There are several types of dielectric oil. We refer to type 1 oil, type 2 oil. Type 2 oil is usually enriched with inhibitor compounds, which are added to the oil to slow down the oxidation process. And what happens is that these compounds react with oxygen and various other elements that can cause decomposition of the oil. And the products of that reaction, the residue, is not harmful to the dielectric oil at all. Next slide, please. So the permissible inhibitor content for transformer should be more than 0.2%, but less than 0.3% by weight of the liquid, which is important to remember. We use weight, not volume, when we calculate the inhibitor amount. So we do it in kilograms or pounds or whatever the case may be, and not liters or gallons. And this is important because if we add more inhibitor than we need, this will actually harm oil instead of helping it. So it's important to maintain oxidation inhibitor levels because values less than 0.1% make the oil uninhibited effectively. Anything between 0.2 and 0.1 is uncertain, and values greater than 0.2 and less than 0.3 are actually optimal for the dielectric oil. So when the inhibitor is lost, when it expires, it's important to add it back again if we want to keep the oil within the performance limits of inhibited oil. And remember that we calculate the amount of inhibitor based on the weight of the oil. It's important to remember that the density of the oil is close to, say, 0.87. So the weight of 100 liters of oil is approximately 87 kilograms or so. Next slide, please. So this is an interesting graph here that shows us an example of how important oxidation inhibitors are in the insulating oil in the transformer. In this graph here, we have the blue line that represents the amount of oxidation inhibitor. The red line shows the interfacial tension, and the green line is the acidity or neutralization number of the dielectric oil. So as long as there is a sufficient amount of the oxidation inhibitor in the system, the color, the interfacial tension, and neutralization number are all within acceptable limits. So we can see that when the oxidation inhibitor expires, the changes don't really take place immediately. There is a delay, but we can already see some change in the color of the oil, and this gives us the false impression that there is no problem with the transformer, which is not true, because what happens is that the transformer itself works as a filter, I guess, of sorts that absorbs the pollutants, and gradually the oil becomes darker. Then you can see there is an important point in this diagram when the oil becomes darker sharply. So you can see that, and this is when interfacial tension plummets and the acidity starts to rise dramatically. So this is because the transformer is saturated with these contaminants, can no longer absorb them from the oil. And suddenly we have a serious loss in the chemical performance of the oil. And looking at this diagram, it's easy to see that this problem doesn't begin when the oil's properties are deteriorating. It began when the level of oxidation inhibitor dropped. So this is why it's very important to keep track of the oxidation inhibitor level in the transformer. Next slide, please. So, right, whenever we regenerate the oil, we affect the oil in three large areas or fields. We're going to have, this process is going to have physical effects because we're going to change the viscosity or improve the viscosity, interfacial tension, visual appearance, among other physical properties of the oil. We'll also change or improve the electrical performance, such as the power factor and breakdown voltage. And we're going to influence the chemical characteristics, such as the neutralization number and inhibitor content. So as you can see, this process really impacts the oil on a large scale and changes many parameters. Next slide, please. I've mentioned that regeneration process involves percolation and absorbance. So what we do is we regenerate oil using Fuller's earth. There are other processes, they're less common. Even the standards don't mention those much. The IEC 6422 standard defines Fuller's earth as an active material that contains active polar substances internally and externally. And this allows the non-polar compounds, the oil basically, to pass unhindered. And it captures the polar contaminants or the decomposition compounds that are dissolved in the oil. Fuller's earth itself is a material that's obtained as a result of processing certain ores originally mined in Brazil. But Fuller's earth can also be found in Georgia, in the Crimea, and in quite a few locations around Europe. And it has long been used to bleach wool, and hence the name, original name, the bleaching clay. Initially, farmers used that Fuller's earth to remove the grease stains from wool, and this is how the name came to be. Next slide, please. There are two types of these clays, LVM and RVM. The difference between them is that one operates well at higher temperatures, the other becomes active at lower temperatures. And these types of clay are different, and they allow us to use each of them for their specific purpose that they're best suited for. For example, LVM clay has a high absorption capacity for acids. It captures water really well, but it does not improve color much. And so it's not effective in everything. We can achieve good oil parameters, but the color will still remain slightly dark. The RVM clay, on the other hand, improves the color of the oil a lot more, but it does have a lower water absorption capacity compared to LVM. And the absorption of acids, well, they're approximately equal with LVM. So I don't think that using Fuller's Earth to absorb moisture is a good idea, because there are more economical and simpler processes for that purpose. That includes thermal vacuum to remove moisture. In addition, the thermal vacuum process doesn't really involve consumables, so unlike Fuller's Earth. For Fuller's Earth, however, there comes a moment when its properties are finally depleted or exhausted, and it needs to be disposed of. And of course, this must be done in a safe manner, because saturated Fuller's Earth is a hazardous waste, and its disposal entails significant costs. But good news, and again, I'll come back to this in a few minutes, Fuller's Earth can also be reactivated and used again up to 300 times under certain conditions. Again, this depends. The amount of reactivations really depends on quite a few parameters. But like I said, we'll get back to that in a minute. Next slide, please. So for use in transformer maintenance, we got two types of Fuller's Earth. The first type is AARVM. That's the Fuller's Earth with maximum bleaching ability. It's recommended for use in moisture-free systems. And there's also AALVM, or that removes acid in humid oil really well. And this slide shows a microscopic image of the pores inside Fuller's Earth that actually trap the contaminants in them. Next slide, please. Right. So if we touch on the topic of material and regeneration process, the first thing we get asked about is how much oil can be processed with a certain amount of Fuller's Earth. So it's variable. The IEEE C57637 standard has a table where you can see how much Fuller's Earth is necessary to process a gallon of oil. This table shows the initial neutralization number, that is the neutralization number in the oil at the time of sampling. And in our chart, we see marks from 0 to 2. And remember that 2 is a very high value because the maximum acceptable value is 0.2. And yeah, thank you. So basically, with an increase in the initial neutralization number, the required amount of Fuller's Earth increases proportionally. These curves here in this graph show the final desired values in the regenerated oil. So let's make a projection from our initial value to our desired value. Let's plot it along the y-axis. And this will allow us to determine the amount of Fuller's Earth in pounds that is needed to regenerate 1 gallon of oil. So the absorbent capacity of Fuller's Earth is influenced by many parameters. It can be temperature, the flow rate of the oil, viscosity of the oil, acid number. So the European standard specifies a temperature of 60 degrees. There are commercial processes like the globe core process that don't use heating, and there are processes that do. It's the topic of some controversy because with incorrect heating, correct use of heating, according to some sources, processing the oil with Fuller's Earth and heating it might activate corrosive sulfur. However, in globe core equipment, that is the focus of our discussion, I guess, is heating is not used in the regeneration process. Let's go to the next slide. Thank you. Excuse me for a second. I guess let's go back, one slide back. Right. So yeah, let's talk about this neutralization for a minute. Let's take a certain value and assume that or assume an initial neutralization number of 0.8. So we want to achieve 0.05. So we should be careful because this is important. We have 0.8, so let's move our line to the desired value, our final number. So we want to achieve 0.05. So when translating this value along the y-axis, it turns out that we'll need approximately 1.7 pounds full reserve for every gallon of oil that we regenerate. Now, let's look at the regenerative capacity of one of our regular plants. One of the best-selling units, specifically our 2-column model, where each column contains 130 kilograms of full reserve. Well, we can use that to regenerate 1,276 liters of oil. Now, 1,200 liters of oil is a small amount. Rather, it's an amount that is probably contained in a 1 MVA transformer. So since we say that we use 260 kilograms of full reserve, that is the equivalent of 286 pounds. So for both columns, that would be 573 pounds. So we have to use a significant amount of full reserve to generate a relatively small amount of oil. However, there is a catch. If we use the technology that allows us to reactivate that same full reserve, and for example, in glow pore machines, we can reactivate it up to 300 times, the numbers really change. So it turns out that the same amount of full reserve, that is 260 kilograms or nearly 600 pounds, we can suddenly regenerate 300 times more oil. And the total comes up to 382,000 liters. So if we go from 1,200 liters to almost 400,000 liters, that's very serious because we do this with the same 260 kilograms of full reserve. So it's obvious that the technology that allows reactivation of sorbent is quite a bit more efficient. All right. Just a second now. Let's please take 1 minute because I think I need to take a quick drink of water. My throat is really parched. Just a few moments, and I'll be back with you. All right, so let's, yeah. Anyway, regeneration itself is also important because it prevents waste. And I guess we can go to the next slide now. Yeah, before we talk about environmental impacts, let's talk about the another solution that is possible, and that is the change of oil. So why don't we just change the oil and not regenerate it? So, okay, if a company doesn't have dedicated dielectric regeneration equipment, that might be okay, but still, it's just a palliative process. It has limited results because when oil is removed from the transformer, a significant amount of that oil still remains in the paper insulation because paper is oil impregnated. So we can see that we cannot remove everything from the transformer by just pumping out the oil. We need to stop the transformer to extract the oil from it. So there is also the downtime for the equipment, which can be costly. There needs to be a passage of time after we fill the transformer with new oil before that oil settles and becomes homogeneous before we can turn the transformer back on. So all of these things mean losses for us, and they tend to occur frequently. So it comes up, the cost of oil change actually comes up to be more than the cost of the regeneration equipment and the process. And again, it's important to remember that a significant amount of contaminants still remain inside the transformer. These contaminants actually act as catalysts, accelerating the degradation of that new oil that we just put into the transformer. So in something less than 1 year, the new oil will just basically be the same as that old oil that we just changed. And that oil would ideally require regeneration. And again, if we're talking about large volumes of oil, all this old oil from the transformer, there is the problem of disposal. And then we need to prepare new oil and prepare new oil. So it's all a big hassle that can be avoided if we regenerate the oil. So an oil change process is just generates waste oil. It wastes our time. It's also a process that doesn't achieve any long-term results. This is probably the most important part. And when we talk specifically about the equipment that we offer as regeneration solutions, you will see how regeneration actually helps to clean out the transformer to remove the contaminants that are trapped inside the solid insulation paper. Right, so let's go to the next slide now. Next slide, please. Yeah, so the environmental impact of dumping the oil, if we change the oil, basically it's bad. Generally, as we are all aware, the environmental footprint of industries is quite significant, and the good thing is that it's becoming more important for businesses, and it's becoming more important for companies to approach regeneration of oil more professionally. So mineral-based dielectric oils in our transformers is a hazardous pollutant, and it's also a human health hazard and remains so throughout the entire life cycle and even after that. So the greatest harm that the electric oil does, it does it to aquatic ecosystems and to human health. And it can contaminate the environment in many ways. Spills can contaminate soils, but if it gets into water, that's really bad. So used oil is a very strong pollutant. It's about 5,000 times more harmful than wastewater from sewage systems and water treatment systems. So 1 liter of oil actually contaminates about 40,000 liters of water. So that would be 40,000 liters of water. This is something like an annual per capita household consumption of water. So you can see how this is significant. Next slide, please. Right, so the regeneration of oil, however, reduces that environmental footprint, and it also offers excellent benefits for the oil-filled equipment in the long run. Regeneration eliminates the consumption of thousands of liters of oil, and the time costs are also reduced because it's possible to regenerate the oil online. It means that we don't have to turn off the transformer to regenerate the oil. Of course, this involves some safety precautions, but it's entirely possible. Another important thing is that there is no need to wait for the paper to be impregnated with oil when we add new oil into the transformer, and because and we don't need to add more oil as oil impregnates the paper and the level drops, so that problem is eliminated as well. Another important point in favor of the regeneration process is the effect it has on the contaminants that are trapped in transformer windings in that same paper. Because during the processing of the oils, if we do this inside the transformer while the transformer is on, there is a certain vibration in the transformer when it's on, and the oil that goes to regeneration carries out the contaminants, and it comes back into the transformer cleaner, so it can accept and absorb or dissolve the contaminants from the cellulose and take it out of the transformer again, and these contaminants are trapped in the regeneration machine. So, and since we do this online, like, we don't have to take the transformer offline. There is no downtime to the transformer, and this is also a good advantage to the regeneration process. And now let's take a look at some of the actual practical examples of how this process is run. Next slide, please. Right, so here you can see the results of operation of a regeneration machine, a CMM6RL. unit that was used in Chile. The photo on the right here shows the unit itself, the plant. And the one on below on the left here shows the samples of transformer oil that was taken before and after regeneration. You can guess the before is to the left and after is to the right. So even in visual appearance, differences in the samples are absolutely clearly visible, right? Next slide, please. Here we have another example of transformer oil regeneration. This was in Guatemala, and we have a brief video to demonstrate it. You'll see that here in this process, the oil goes into a vacuum purification machine, a vacuum dehydration unit, a degassing unit. Here, in just a minute, you'll see how that process works. So in the vacuum dehydration machine, what happens is that oil is subjected to heat and vacuum that extracts any gases from the oil and any moisture, right? So here you can see the, or in a minute, you can see the control panel of the machine. This is the oil, the dirty oil that goes, that comes into the regen machine from the transformer, and the clear line on the right, the hose with the clear oil, is the oil after regeneration. And you can, even through these semi-transparent hoses, you can already see the difference. And this is done on the transformer without turning it off, so you can see how the clear regenerated oil goes back into the transformer from the top. Right. The next slide we have is from Greece. Again, and that was an interesting example. So in 2020 in Greece, all the electrical insulating oil was drained from high voltage switches and a 40-year-old transformer, and that all was regenerated. And in the video here, you can see the CMM12R unit. The 12 stands for 12 columns with absorption material, and the machine ran automatically without any operator intervention. It restored the oil completely to as good as new condition. The oil was in the amount of 7 tons, and this process was performed in 2 passes through the regeneration columns. Between the 2 passes, the sorbent in the columns was reactivated, and the sorbent reactivation process takes about 15 hours, and in this case, it was automatically managed by the PLC. Here you can see the difference in color of the oil. This is the flow rate, and this is the color of the incoming oil and the color of the outgoing oil on the left. If you do this process in several cycles, you can achieve like very clear color of the oil. This is the degassing machine that I've mentioned. The oil flows in the vacuum chamber, and gases and moisture are removed. This is the control panel. It's very convenient controls, and everything is automated pretty much. So just set up the process parameters, hit start, and it works on its own pretty much. So yeah, on the subject of controls, the CMM12R has a very smooth and accurate management of the regeneration process in terms of a flow rate, the control of the moisture content and color. It measures color of the oil as well. There is the soft heating, and there is the oil degassing, as you've seen after regeneration. And as the regeneration machines do, it can work on energized transformers. And here you will see the results, how the color progressed from really dark to something much clearer. It's also possible to monitor the processes remotely. This is available on the CMM12R unit. The operator controlled the reactivation process, for example, absolutely remotely. And after reactivation, the sorbent was again used for regeneration without the need to load and unload the sorbent. And this property allows the sorbent to be reactivated around 300 times or so. It does depend on the quality of oil, obviously. if we use the sorbent with really bad oil all the time, I guess the 300 times will go down a little bit, but it's a good baseline figure, 300 times. Okay. Next slide, please. So, all right. Now let's talk about a CMM6RL machine. 6 means the 6 columns with Fuller's earth. So the most important components are, of course, the columns with Fuller's earth. What they do is they hold the absorbent material, and that material removes contaminants from the dielectric oil that flows down these columns. These columns also have inbuilt heaters on the top. When we need to reactivate the sorbent, these heaters raise the temperature of the material. They start for a short time, and then the Fuller's earth is ignited by these heaters, and this is the process that is the reactivation of Fuller's earth. In the columns here, you can see there's a group of temperature sensors that monitor the temperature of the Fuller's earth during the reactivation process. And basically, the reactivation process is burning, a lot like a cigarette or a cigar. A burning layer moves from the top to the bottom of the column, and it's very important to monitor the temperature of the process so that we know just how far into the process we are and what the temperatures are. If the temperatures are exceeding a certain limit, that means we have a problem, or temperatures are cooler than we expect, and maybe the process is not going right as well. So one column has, I think it's 6 sensors, and the rest have only one. One column is the control column, and we assume that the process in the other columns runs pretty much the same as in the first control column. Okay. So the valves at the top of the columns are used to obviously control which column is used for what. It's possible to use part of the columns for generation, and part of the columns are in reactivation mode if necessary. And every column contains approximately 130 kilograms of Fuller's earth. That means that the unit can process quite a significant amount of oil, especially if we consider the reactivation cycles. Next slide, please. These are the buffer tanks in the machine. These containers are designed to contain oil, both for processes in which the oil level drops as a result of the regeneration process, and for the reactivation of the absorbent material. An additional characteristic of these tanks is that there are actually 2 of them, 2 tanks in one. Inside the main tank, you can see there is one more smaller tank that collects pollutants and water and condensate during the Fuller's earth reactivation process. So when the reactivation process is over, the oil from the buffer tank is returned to the columns, and that prevents any drop of oil level inside the transformer. So we don't lose any oil here. These tanks have a level indicator that would allow the operator to estimate the amount of oil inside. And they have a maximum level, high level sensor that signals when their upper level in the tank is reached. Next slide, please. And then there is the pumping system or the suction system. What it does, it pulls air or circulates air through the Fuller's earth columns. It has 2 fundamental functions or purposes. First, it is used to increase the temperature during reactivation because of the constant passage of air in conjunction with the temperature that the heater creates ensures the full ignition of Fuller's earth that burns out all of the captured pollutants. And with the constant air circulation, the fire, that burning, spreads through the columns evenly. And the second function is that after completion of the burning, the reactivation, the system increases the amount of passing air. And since there is no more burning, basically what it does is cools down the sorbent, which is necessary when we need to start processing oil and regenerating oil again after sorbent reactivation. And the system is also equipped with a carbon filter. It's important to prevent any of the contaminated exhaust from going into the environment unscrubbed. So this charcoal filter is important to make the process as environmentally friendly as possible. Okay. Next slide, please. And here we have a general view of the process, I guess, a process diagram. Right, so the oil passes through the columns The columns, the absorbent material in the columns captures the degradation products from the oil. So first, the columns are filled with oil. And as soon as the need arises to reactivate Fuller's Earth, when the Fuller's Earth is saturated, the oil from the columns is drained, and the process of burning the pollutants inside the columns can now be started. And as soon as the high temperature process is over and the temperature in the columns decreases, the oil from the buffer tank enters the columns again, and the regeneration process is resumed. And in the following slides, you'll be able to see that process animated. Next slide, please. Right. So in this animation, we can see how oil is pumped and distributed to each of the columns with Fuller's Earth. And once the oil passes through the Fuller's Earth, it's returned to the transformer, or maybe we work from an external tank, so we can return it to the tank. Depends also on our setup. The amount of the oil that we can process in one time depends on the quality of the oil before we need to reactivate the sorbent. It's very important to carefully manage the processing rate, as one of the main variables in the regeneration process is the time that the oil spends in the columns, or retention time, right? So the passage of oil at reduced speed, at a reduced rate, can actually improve the results of the process. And as soon as the capacity of the Fuller's Earth is fully exhausted, it needs to be reactivated. And this process we can see in the next slide. Next slide, please. Right, the reactivation process, it begins with the passage of air through the columns, after which the oil from the columns is pumped into the buffer tank. And after this oil is pumped out, the material inside the columns is ignited by the heaters on top of each column. And the temperatures of this process are in the range of something like 750 degrees Celsius. And at this temperature, all of the degradation products that we captured from the oil are burned out or removed into the exhaust and the filter. So when the temperature in the columns rises, the remaining oil is transferred to the contaminated oil container. And the absorbent is blown through with a strong stream of air. And when the temperature drops again, then the plant is ready to continue the dielectrical regeneration process. And this is a cycle that can be repeated 200 to 300 times. And as we've calculated before, this translates into significant amounts of regenerated oil on a limited load of sorbent. So there is a lot more to the regeneration process than this. This presentation was really a bare bones explanation of how this works. But I'm sure you have quite a few questions. They can be sent to our email, and no question will go unanswered. We'll address each and every one of them. Also, if you need a certificate of being here, a participation certificate, let us know by email or write into the presentation chat here, and somebody will get back to you on that. So I would like to thank you all for being here and for bearing with me for this 1 hour. It was an honor to present this information to you, and I hope to see you again. Stay tuned, watch announcements on our website. We'll have more information to share with you pretty soon. Thank you.